Split bolts should not be used in permanent electrical installations. They are considered temporary connections and are not suitable for high currents or long-term use. Emergency circuits must be separated from non-emergency circuits throughout their entire length. Splicing them in the panel is a violation of this requirement. The auto-transfer switch should isolate the backup generator from the utility supply. A 90-amp breaker in the main panel feeding back to the backup panel defeats this isolation purpose. Improper connections can lead to electrical fires, shocks, or electrocution. Violating electrical codes can result in failed inspections and permit revocations. If any injuries or damages occur due to these violations, the responsible contractor could be held liable. Corrective actions include removing split bolt connections and replacing them with permanent connectors. Separate emergency circuits from non-emergency circuits throughout their entire length. Install a double throw transfer switch with isolation to prevent the backup generator from feeding back into the main panel. These violations are common in unlicensed electrical work. It is important to hire qualified and licensed electricians to ensure electrical systems are installed and maintained in accordance with code. Always inspect electrical installations before accepting them as complete. Electrical safety is paramount, and adherence to the National Electrical Code is essential for protecting people and property from electrical hazards. Several common violations can compromise this safety, leading to potential fires, shocks, and equipment damage. Understanding these violations and how to correct them is crucial for electricians, inspectors, and homeowners alike. One of the most basic, yet often overlooked, violations involves the use of split bolt connectors in permanent electrical installations. Split bolts, also known as split bolt connectors, are mechanical connectors designed for temporary connections such as grounding electrodes during construction. They are not designed for long-term use or high current applications. The primary issue with split bolts is their susceptibility to loosening over time. As the conductors expand and contract with temperature changes, the clamping force of the split bolt can diminish, leading to increased resistance at the connection. This increased resistance generates heat, which further accelerates the loosening process and can ultimately result in a thermal runaway and fire. Furthermore, split bolts are typically not insulated, leaving the connection exposed to environmental factors like moisture and corrosion. This can further degrade the connection and increase the risk of electrical failure. The National Electrical Code mandates the use of listed and labeled connectors for all permanent electrical connections. These connectors are designed and tested to maintain a secure and reliable connection over the lifespan of the electrical system. Acceptable alternatives to split bolts include compression connectors, insulated tap connectors, and terminal blocks. These connectors provide a gas-tight connection that resists loosening and corrosion, ensuring a safe and reliable electrical pathway. Another critical area of concern involves emergency circuits. Emergency circuits, which power essential equipment during power outages, must be physically and electrically separated from normal circuits. This separation ensures that emergency power is available when needed and prevents the propagation of faults from normal circuits to emergency circuits. A common violation occurs when emergency circuits are spliced into normal circuits within the electrical panel. This practice compromises the isolation of the emergency system and can lead to the failure of critical equipment during an outage. The National Electrical Code requires that emergency circuits be wired in a separate raceway or cable assembly from normal circuits. This physical separation prevents accidental contact between the two systems and ensures that a fault in one system will not affect the other. Within the electrical panel, emergency circuits must be terminated on dedicated breakers and terminal blocks that are clearly labeled and identified. This helps to prevent confusion and ensures that only authorized personnel can access or modify the emergency system. The transfer switch is a critical component of an emergency power system. It automatically switches the load from the utility power source to the backup generator when a power outage occurs. The transfer switch must also prevent the backup generator from feeding power back into the utility grid, which can create a dangerous situation for utility workers and damage electrical equipment. A common violation occurs when the transfer switch is improperly wired, allowing the backup generator to backfeed into the main panel. This can happen if the transfer switch is not a double throw design, which provides a positive break between the two power sources. A double throw transfer switch has three positions: utility power, off, and generator power. In the off position, both the utility and generator power sources are completely disconnected from the load, preventing any possibility of backfeed. The National Electrical Code requires that all transfer switches be listed and labeled for their intended use. The transfer switch must also be installed in accordance with the manufacturer's instructions and all applicable electrical codes. In addition to these specific violations, there are several general safety hazards associated with substandard electrical work. Improperly sized conductors can overheat and cause fires. Loose connections can create arc faults, which are a leading cause of electrical fires. And grounded equipment can pose a shock hazard. The consequences of electrical code violations can be severe. Electrical fires can cause significant property damage, injuries, and even fatalities. Electrical shocks can range from mild tingling to cardiac arrest. Code violations can also result in failed inspections, permit revocations, and legal liability. To ensure electrical safety and code compliance, it is essential to hire qualified and licensed electricians. Licensed electricians have the training, experience, and knowledge to install and maintain electrical systems in accordance with all applicable codes and standards. Homeowners should always verify that an electrician is licensed before hiring them to perform any electrical work. It is also important to inspect electrical installations before accepting them as complete. Look for obvious signs of code violations, such as exposed wiring, loose connections, and improperly sized conductors. If you are unsure about something, consult with a qualified electrical inspector. Correcting electrical code violations can be a complex and expensive undertaking. However, the cost of correction is far less than the potential consequences of ignoring these violations. By taking the necessary steps to ensure electrical safety and code compliance, you can protect yourself, your family, and your property from electrical hazards. Furthermore, it is important to note that electrical codes are constantly evolving to address new technologies and safety concerns. Staying up to date on the latest code requirements is essential for all electricians and electrical inspectors. Continuing education courses and professional development opportunities can help to ensure that electrical professionals have the knowledge and skills necessary to perform their jobs safely and effectively. In conclusion, electrical code violations are a serious matter that can have devastating consequences. By understanding the common violations, the safety hazards they create, and the steps necessary to correct them, you can help to ensure the safety and reliability of electrical systems. Always hire qualified and licensed electricians, inspect electrical installations thoroughly, and stay up to date on the latest code requirements. Electrical safety is a shared responsibility, and we all have a role to play in preventing electrical accidents. Remember to always disconnect power before working on any electrical equipment. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If you are unsure about something, consult with a qualified electrician. Electricity is a powerful force that can be both beneficial and dangerous. By respecting electricity and following safety precautions, you can minimize the risk of electrical accidents and ensure a safe and reliable electrical system. When evaluating electrical work performed by others, especially in older installations, several key areas deserve close attention. Firstly, the type of wiring you used is critical. Older homes may still have knob and tube wiring, which is an outdated and potentially hazardous system. Knob and tube wiring lacks a grounding conductor and often has insulation that has deteriorated over time. Replacing knob and tube wiring with modern wiring methods, such as non-metallic sheath cable, is highly recommended. Secondly, the condition of the electrical panel is important. The panel should be properly sized for the load it serves and should have adequate overcurrent protection for each circuit. Look for signs of corrosion, overheating, or damage to the breakers or bus bars. If the panel is old or undersized, it should be replaced with a new panel that meets current code requirements. Thirdly, the grounding system should be inspected. A properly grounded electrical system provides a low impedance path for fault current to return to the source, which helps to prevent electrical shocks and fires. The grounding system should include a grounding electrode, such as a ground rod or water pipe, and a grounding conductor that connects the equipment grounding conductors to the grounding electrode. Fourthly, the presence of ground fault circuit interrupters, or GFCIs, should be verified. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs monitor the current flowing in the circuit and trip if there is a difference of more than a few milliamperes between the hot and neutral conductors. This can prevent a potentially lethal electrical shock. Fifthly, the use of arc fault circuit interrupters, or SIs, should be considered. SIs are designed to detect arc faults, which are a common cause of electrical fires. SIs monitor the current flowing in the circuit and trip if they detect an arc fault signature. SIs are required in many new homes and are recommended for older homes as well. Sixthly, the proper labeling of circuits is essential for safety and convenience. Each circuit breaker should be clearly labeled to indicate the equipment or area it serves. This helps to prevent confusion and ensures that the correct breaker is turned off when working on electrical equipment. Seventhly, the use of extension cords should be minimized. Extension cords are intended for temporary use only and should not be used as a substitute for permanent wiring. If you find yourself relying on extension cords frequently, it is a sign that you need to add more outlets. Eighthly, the presence of smoke detectors and carbon monoxide detectors should be verified. Smoke detectors are required in all homes and should be located on each level and in each sleeping area. Carbon monoxide detectors are required in homes that have fuel-burning appliances, such as furnaces, water heaters, and stoves. Ninthly, the condition of electrical outlets and switches should be inspected. Look for signs of damage, such as cracks, chips, or loose connections. Replace any damaged outlets or switches immediately. Tenthly, the presence of surge protection should be considered. Surge protection can help to protect sensitive electronic equipment from damage caused by power surges. Surge protection devices can be installed at the electrical panel or at individual outlets. By paying attention to these key areas, you can identify potential electrical hazards and take steps to correct them. Remember, electrical safety is an ongoing process that requires vigilance and attention to detail. In addition to these specific points, consider the overall condition of the electrical system. Does it appear to be well maintained and up to date? Are there any obvious signs of neglect or abuse? If you have any concerns, it is always best to consult with a qualified electrician. They can perform a thorough inspection of the electrical system and provide recommendations for any necessary repairs or upgrades. Furthermore, when making any electrical modifications or additions, always obtain the necessary permits and inspections. This ensures that the work is performed in accordance with all applicable codes and standards. The inspection process helps to identify any potential problems and ensures that the electrical system is safe and reliable. Electrical work can be dangerous, and it is always best to leave it to the professionals. Unless you have the training, experience, and knowledge to perform electrical work safely, you should always hire a qualified electrician. Working with electricity can be hazardous, and even a small mistake can have serious consequences.